Physical Science Exam 2015, question 4. The specifications of an aeroplane that uses Hobart Airport are the thrust force of each of the two engines is 120 kilonewtons. The maximum takeoff weight is 73.5 tonnes. Maximum landing weight is 64.5 tonnes. And the takeoff speed is 79.6 metres per second. Identify the term that is incorrectly used in the specification and explain. Well, the incorrect term is going to be the takeoff weight because it's expressed in tonnes. So what we actually have is the takeoff mass. Mass is 73.5 tonnes. If you're going to find out what the weight is, the takeoff weight is equal to the mass times gravity, which equals 73.5 times 10 to the 3 kilograms multiplied by 9.81 equals 73.5 x to the 3 times 9.81, which equals 721,000, which equals 721 kilonewtons. And that is going to be the takeoff weight is in kilonewtons because that's a force, but the takeoff mass is in tonnes. Now you could either say that for the minimum takeoff weight or the maximum takeoff weight, it's the weight and the tonnes that are the issue here. Why is there a difference between the maximum takeoff weight and the minimum takeoff weight? Because when you take off, you are chock-a-block full of fuel, and when you are not coming back, you would hopefully not be chock-a-block full of fuel. So we have the difference between those is the mass of the fuel is the difference between takeoff and landing. Oh. What's today's? Where is mine? There we go. Landing. Show the acceleration of this fully loaded aeroplane as it takes off is approximately 3.3 meters per second squared, assuming all the force from the engines is available. So we have the acceleration is going to be equal to force equals mass times acceleration. So we have from here the force of each of these. Force equals 2 multiplied by 120 kilonewtons. Now, if we look on the inside of our front cover of the information sheet, you will see that we have the prefixes here. Kilo is 10 to the 3 kilograms, so this one's kilonewtons, so we're going to have 10 to the 3, so let's go 120 times 10 to the 3 newtons, which equals, we don't really need the calculator for that, but I'll do it anyway, times 2 times 120 x to the 3 equals 240,000 newtons, or 240,000 newtons. Show the acceleration. This is approximately 3.3. Well, we do that because the maximum takeoff weight is 73.5 tonnes. Or we've already shown that it's going to be mass, so I'll just put mass there to show what's going on. That is going to be m equals 73.5 by 10 to the 3 kilograms, because 1 tonne is equal to 1,000 kilograms. And since F equals ma, this implies that A is equal to F divided by m. So acceleration is going to be equal to 240,000 divided by 73.5 by 10 to the 3. And I know that's not quite correct in terms of the scientific notation, but for the sake of this it won't matter. Divided by 73.5 x to the 3 equals 3.27. Squared. Calculate the minimum length of runway required for the aeroplane to take off. Well, if it's going to take off and it's accelerating at 3.2 meters per second squared, and it needs to get to a speed of 79.6 meters per second, and we don't know the distance, then we can sort that out. It started from rest, so u is equal to 0, v is equal to 79.6 meters per second. A is equal to 3.27 meters per second squared, and S is equal to, we don't know. And which one of these ones are we going to use? I reckon it's probably one of the ones we haven't used before. Oops. Steer away from chemistry. We'll do that later on. Come back here to the information sheet, and we look here. The V squared equals U squared plus 2AS. That's the one we're looking for. V squared equals U squared plus 2AS. So we have here 79.6 squared equals 0 plus 2 multiplied by 3.27 times S. So that's going to go, and we just divide through by that. So 2 multiplied by 3.27 equals 6.54. So 79.6 squared equals 6.54 times S. Divide through both sides, and we get, let's divide through by both sides. Cancel that out. We get 79.6 squared divided by 6.54 equals 968.8. So 900 and, shall we say 969 meters? We wouldn't want to cut ourselves short on the runway. So S equals 969 meters. Hooray!